Hello class, welcome to Algebra Lesson 5.2, which is all about piecewise defined functions. By the end of this lesson, you should be able to graph and apply piecewise defined functions. So just to help you kind of get an idea of what a piecewise defined function is, if we were to have a coordinate plane, a piecewise function is sometimes going to look really kind of goofy, honestly. You might have something that looks like this where you have an endpoint and then an arrow going another way, and then below it there might be an open circle and it goes to another endpoint and it looks something like that. That's an example of a piecewise defined function, and it's just going to look like it's pieced together, okay? One thing to note about piecewise defined functions, notice that when I drew that, I had one open circle, and then below it I had one closed circle, and then below it I had an open circle. So that way, remember we talked a couple chapters ago about the vertical line test. If I was to draw a straight up and down line, a vertical line, through any point on this graph, it would only ever touch one space, because remember, an open circle doesn't count. So in order to remain a function, when you are piecing these together, if there's something that's like right above and below each other, one circle needs to be open and one circle can be closed. Okay? So let's move on. So let's talk about understanding piecewise defined functions. Yesterday we talked about the absolute value function, and that's kind of what's drawn over there on the right. But we're going to talk about how we can maybe change this absolute value function into a piecewise defined function. Okay, so that means that I'm going to look at this graph. I am told that it's 2 times the absolute value of x, and I'm going to look at it 2 different ways. I'm going to say I have a closed circle and this line, right? And if I really, really wanted to, I could continue drawing this line that way, right? And if I were to write the equation of this line, it would be y equals, my slope is 2, and then x, and then my y-intercept would be 0, so I could write plus 0, but I'm just going to get rid of that plus 0. And then where does this graph start? This graph starts when x is equal to 0, so, and then it goes towards the greater than. So x is greater than or equal to 0 would give me just that part of that line. Now, if I were to look at this line, this time I would not want to include 0, so I'm going to do an open circle. And how would I write an equation for this line? This time my slope is going down, so this is a negative 2 slope. So I'd say y equals negative 2x. And then again, the y-intercept would be 0. But this time, I'm looking at all of the x values that are, less than 0. I'm not going to do the less than or equal to because I want it to be an open circle at 0. So the way I would write this as a piecewise function, I would say f of x equals, and then you're going to do a big squiggly bracket. So in case you need a refresher on how to draw that, do an S and then do a backwards S. Okay? I know that is tough, and if the best you can do is something like that, that is okay. All right? I know it takes some practice to be able to do a squiggly bracket. Now, you're going to write both of those things. You're going to say 2x. You don't have to put a y equals anymore because you already have an f of x equals. So you're going to say f of x equals squiggly bracket 2x, comma, it's 2x when x is greater than or equal to 0. and then it's a negative 2x for the line when x is less than 0. And that's how you would write this function as a piecewise function. It's going to have multiple lines with multiple equations. Okay? So I want you to think about this piecewise function. So express f of x equals negative 3 times the absolute value of x as a piecewise defined function. So again, you're going to have f of x equals big squiggly bracket, and then you're going to have two different lines. But pay attention, we have a negative 3x, so or negative 3 times the absolute value of x. So think about how if we have negative, it flips, right? So what would that equation look like? Or those equations? Good luck. All right. Hopefully for this one, you realized that when x is greater than 0, greater than or equal to 0, that's this right-hand side over here, my slope is negative, right? It's going down and right. So that's a negative 3x. And then when x is less than 0, that's that lighter blue, and that is just a positive 3x when x is less than 0. All right, so what is the graph of f of x equals? What if we have more complicated lines where they're not exactly the same? So we have x plus 1 when x is less than or equal to 2. So if x is less than or equal to 2, what we can do is, if you want to make a table, so x, y, x is less than or equal to 2, so 2, 1, 0, negative 1, negative 2. 2 plus 1 is 3, 1 plus 1 is 2, 0 plus 1 is 1, negative 1 plus 1 is 0, negative 2 plus 1 is negative 1. And if you were to plot those points, you would have this line right here. Okay? And then, if we look at the other line, we have negative 3 halves x plus 6. So when x is greater than 2. So again, if you make xy, and I'm going with greater than 2, what I can do is draw an open circle at 2, and I would say if I plug 2 in, I would have 3. So that's where I can put that open circle. Sorry, that should be open. Let's see if I can redraw that. So then it would be an open circle at 3, and then if I were to plug in, say I did like 4, that would be 0. There's that, and you can just connect those lines. And the reason I don't have to leave an open circle there is because that red line fills in that value at 2. That's why it just looks like these two lines are connected. Okay? So if you remember how to graph lines, you're going to be just fine. If you need a refresher on how to graph lines beyond what I'm doing in this video, please be sure to ask, okay? And then one last thing that you'll sometimes be asked is to determine over what part of the domain. So remember, domain means your x values. So over what part of the domain is the function increasing, and over what part of the domain is the function decreasing. So we have, if we look at our x values, from here to here, our line is going up, right? And then from here to here, our line is going down, right? Our y values are increasing when x is less than or equal to 2, and then it's decreasing when x is greater than 2. All right. I want you to take a moment to practice graphing on your own, okay? So graph the following function. F of x equals x minus 2 when x is less than or equal to 1, and negative 2x plus 3 when x is greater than 1. Good luck. Okay, hopefully when you graphed it, you ended up with something that looks like this. It's going to be different. And if you were a little confused on why the circles weren't overlapping or you thought you did something wrong, you didn't. Piecewise functions, just like that very first drawing I did for you, they don't have to overlap. They don't have to be connected. They can be two completely separate lines. Okay, so you just have to pay attention to when you're going to have an open circle versus when you're going to have a closed circle. And this would be your graph. So if you have questions on that, please be sure to reach out for some help. I'm happy to help you. Let's look at analyzing piecewise-defined functions. So one thing I love about piecewise functions is it is very real world. Okay? There are a lot of real world applications. So in this example, we're talking about looking at water bills. And you might think, or you might not know because many of you are too young to be paying water bills, you might not know that depending on how much water you use, there are different prices that you get charged based on your water usage. The more and more you use, the more and more expensive each amount of water is. Okay? And then also, a more realistic application of this or not realistic because this is a realistic example, but relatable, cell phone bills, talking about data and the cost of, like, say you have unlimited talk and text, which is pretty much all that any of you have ever known. Unlimited talk and text, but data. You might have unlimited data, or your family might pay different amounts each month based on how much data you use. Okay? So Cheyenne's mother is reviewing the monthly water bills from the summer. Each monthly bill includes a graph like the one shown, which reflects the different rates charged for water based on usage. Several relatives visited Cheyenne's family in July, and their water bill more than doubled. Assuming that water consumption did not double that month, what is the possible explanation for the increase? So if we look at this graph, we have three different sections, right? We have that red section, which is called Tier 1 in the graph, and Tier 1 focuses on, let's see, sorry, I'm trying to get a better pen. That one's pretty thick, oh well. So Tier 1 goes from 0 gallons of water all the way up to, it includes, that would be 5 gallons, or not 5 gallons, but these are thousands, so 5,000 gallons of water. And that would be the cost. If we used 5,000 gallons of water, we're going to pay $5. If, however, we use more than 5,000 gallons of water, so this open circle tells me that if we use 5,001 gallons of water, all the way up to, that would be 10,000 gallons of water. Don't know why the color switched. That's frustrating. 5,001 through 10,000 gallons of water. If we use 10,000 gallons of water, that's going to be $20. If, say, we used even more than 10,000 gallons of water, so say we used 10,001 or more, so I'm going to say 10,001 plus, that's going to be jump all the way up to $30 a month or higher. It's just going to keep increasing as we go. Okay, so you see how there are different ranges of cost. The more and more water you use, the faster and faster the water bill jumps, right? So what is a possible explanation for the increase? Honestly, it could just be that they used enough water to jump up a tier. So they might have been in tier 1, but now all of a sudden they are in tier 2, or they are now in tier 3. Okay, so these types of graphs help you determine the different costs. Let's talk about applying a piecewise defined function. So we have a gym owner wants to purchase custom wristbands for a marketing promotion. She thinks she will need about 75 bands. Her assistant insists that ordering over 100 wristbands will be less expensive than ordering 75. How can the assistant convince the gym owner? So first, let's practice writing a piecewise function for this information. So I'm going to write my f of x equals my big squiggly bracket, because I see I have 3 different tiers. That means I'm going to have 3 different equations. Okay? So for that very first tier, we have 0 to 50 wristbands. They are $2 each and $20 shipping. So for that first equation, I would say 2 times x, 2 times however many wristbands they buy, plus, no matter what, I have to pay $20 shipping. But this is only good when you order anywhere from 0 to 50 wristbands. Okay, then if I jump up to the next tier, it's 51 to 100 wristbands. They are $1 each, so 1 times however many wristbands they buy, that'd be 1x, plus 10, because it's $10 shipping. And this time, it is from 50, but I'm not going to include 50, because it'd be 51. Then you'd say x less than or equal to 100. Another way you could write this, if you would prefer to write 51, so you could have the inclusion, I understand why you are getting that, but the reason we don't do that is because then we would have, say that this is our first tier, we have those closed circles. Instead of having something directly above it, it would be off to the side, and that's not what we like for piecewise functions. We like for them to be stacked like that, okay? So that's why instead of writing 51 and including it, you write it as 50 and you do not put the or equal to. Even though you can't buy 50 and a half wristbands, you're still going to do that. Then we have over 100 wristbands as our last one, and those are 50 cents each, so I'm going to do 0.50x, but then free shipping, so I don't have to say plus anything. If I wanted to write plus 0, I could, but that's always unnecessary. So 0.5x, and that would be for 100 is less than x, or you could just say x is greater than 100. Either one is fine. I tend to just like to write x is greater than 100. Okay? That's just my personal preference. So now that I have my piecewise function, how would we convince the assistant gym or the gym owner that ordering 75 is more expensive than ordering 100? So if I order 75, that means I fall into tier 2, right? So I would say x represents 75 wristbands purchased. So f of 75 equals x is 75 plus $10 shipping. That's going to be a total of $85. Then, if we order 100 over 100 wristbands, that means I'd have to order 101 or more. 101, what I'm going to do is I'm going to say 0.50 times 101 plus 0 for the shipping. That is only $50.50. So the assistant's right. If we order 101 wristbands, we're only going to pay $50.50. But if we order 75, we're going to pay $85. So you can see, because of these different tiers, it is actually cheaper to buy more. So that is the argument that the assistant could use to convince the gym owner. Okay? I want you to still keep thinking about this problem. Nothing has changed, but now I want you to figure out what is the difference in cost between one order of 200 wristbands, 2 orders of 100 wristbands each, and 4 orders of 50 wristbands each. So figure out each of those costs and compare them. Good luck. Okay, so for these costs, hopefully you figured out that one order of 200 wristbands is $100. 2 orders of 100 wristbands each would be $220. And 4 orders of 50 wristbands each would be $480. So you can see that's quite a difference, right? So when you're ordering things, it's always a really good idea to check out the different tiers and figure out, is it going to be cheaper to just order a bunch at once? Or is it better to order smaller groups of wristbands, in this case, more often? You can see that when they ordered 4 different shipments of 50 wristbands, they paid a lot more to get those, that would be 200 wristbands, than if they would have just done one order of 200 to begin with. So piecewise functions are a really great way to help you figure out how to save money and just good real-world situations. Here is a nice little concept summary for those of you that like to take screenshots. If you have questions about anything from this video, please don't hesitate to ask. I am more than happy to help you. Have a great day.